Let's talk about partial fraction expansion. Okay, what does this mean? Well, if we have something like 6x squared minus 19x plus 15, and you divide that by x minus 1 times x minus 2 squared, something like this, is there a way that we can split this up into something over each factor? So something over x minus 1 plus something over x minus 2 plus something over x minus 2 squared. Is there a way to split this up? Well, actually, there is, right? And you write it exactly like this to start. And the reason you're able to do this initially is because the degree on top, the square, is smaller than the degree on the bottom, which if you were to expand this, you would have x cubed on the bottom. So because of that, we're allowed to go forward with this process. When that's not the case, we're going to do an example of what you have to do in that situation as well. So just stay tuned for that. But for this case, when the degree on top is smaller than the one on the bottom, you can just go ahead like this, okay? So what you do to start is we're going to multiply everything here by x plus 1 and x minus 2 squared, okay? Because that will clear our denominators. So you'll have 6x squared minus 19x plus 15 is equal to multiply a over x minus 1 by x minus 1, x minus 2 squared. And you're going to end up with a times x minus 2 squared because the x minus 1 and x minus 1 will cancel. Then you'll have b times x minus 1, x minus 2, and then you'll have c, I'm just running out of space so I'm putting it down here, times x plus 1 because the x minus 2 squares will cancel, okay? Next what we have to do is solve for some of these variables, a, b, and c. And the way you can do that is by eliminating a couple of them by plugging in a value for x. So let's say, for example, we let x equal 1. The reason I want to do that is because if you plug in 1 for x here and here, 1 minus 1 is 0, 1 minus 1 is 0. Oh, sorry, it's supposed to be a minus, not a plus. Then those will become 0, a and b will go away, right? So let's do that. You'll have 6 times 1 squared minus 19 times 1 plus 15 equals a times, you have 1 minus 2 squared. Well, 1 minus 2 is negative 1. Negative 1 squared is just 1, so you just get a. And then this is 0, and this is 0 like we said, so those are gone. So you really just have a is equal to this stuff on the left here. So a is equal to 6 minus 19 plus 15. So it's like 6 minus 4, which is just 2. So you solve that, you get 2. So that's our value for a. Now, let's try to solve for c, right? We can solve for c by plugging in a value that will get rid of b, but not c, right? So maybe I plug in a 2, because 2 minus 2 is 0, that'll get rid of that. And then we can solve for c. So, let x equal 2, and you'll have 6 times 2 squared minus 19 times 2 plus 15, and that's going to equal, well, you're going to have 0 times your a plus 0 times your b plus c. So c is just equal to all this on the left. 2 squared is 4, 4 times 6 is 24, minus 19 times 2, which is 38, plus 15, you're going to get c equals 1. Okay, and now we just have to solve for b. So to make it nice and simple, I'm just going to let x equal 0, and that's going to get rid of a bunch of terms for us. So we'll have 0 minus 0 plus 15 equals a times negative 2 plus b times negative 1 times negative 2 plus c times negative 1. And remember, we said c is 1. Get rid of that, put a 1. And we said a is 2, so get rid of the a, put a 2. And then we can isolate for b. Oh, and don't forget this negative 2 here is squared. Can't forget that, very important. Negative 2 squared is 4, times 2 is 8. So on the left here, you'll have 15. Bring that 8 over here, minus 8. 1 times negative 1 is negative 1. Bring that to the other side, you get plus 1. And that's going to equal 2b, because negative 1 times negative 2 is positive 2. So on the left, you have 16 minus 8, which is just 8. So 8 equals 2b. Divide both sides by 2. B is equal to 4. So now you have your a, b, and c values. So we go ahead and we say that therefore the expression we started with is equal to a, which we know is 2, over x minus 1, plus b, which we now know is 4, over x minus 2, plus c, which we learned was 1 over x minus 2 squared. Okay? And you can check your answer by plugging in a value for x into this expression and into the original, and make sure you get the same answer. Now, just to clear up any confusion here as to what we did, when we started, I said I want to break this thing up into different fractions with their denominators being the factors here. So what you have to do to get this to work is you have x minus 1 is one of the factors, so you put it here. X minus 2 is also a factor, so you put it there. Because it's squared, you need a third factor where it's being squared. Okay? That's not incredibly intuitive, right? It's actually kind of a little bit confusing, but if you don't have that there, the answer is not going to work out very nicely. Okay? So we have to include that. Now, with all that said, there's one thing we said about this question at the beginning, if you remember. I said the exponent on top is smaller than the one on the bottom. That's why we could do this. If that's not the case, we have to do something else. So let's look at an example where that's the case. So what if we have something like x squared minus 2x minus 37 divided by x squared minus 3x minus 40. So in this case, the exponent on the bottom isn't bigger than the one on top, right? We said in the first one we want the top exponent to be smaller than the bottom. For this one, it's not the case, right? So since the top one isn't smaller, we have to take some extra steps here, all right? What you're going to have to do is actually some division. You're going to have to do x squared minus 2x minus 37 divided by x squared minus 3x minus 40, which is just what we have written here, right? Just written in a different way. So when you divide this, x squared divided by x squared is 1. So you put a 1 there, multiply it, you get x squared minus 3x minus 40. You go to subtract these, and what do you get? Well, that's 0. Negative 2x minus negative 3x, that's like adding, you get plus x. And then negative 37 plus 40, essentially, you're going to get plus 3. So you get x plus 3 as your remainder, right? So what that means is that this whole thing is equal to 1 plus x plus 3 divided by this bottom here, x squared minus 3x minus 40, right? That makes sense. If you're not familiar with that, then go back and watch our videos on dividing, right? Long dividing and synthetic division. Okay, so this is equal to this. Now, with that being said, the 1 is good on its own, but we have to break down this thing, right? And we can do that because the exponent on the bottom is bigger than on top. Now we got what we want, right? So we can go ahead and do this the same way we were doing it before. One thing you have to do is factor the denominator though. So I'm going to do this work over here, and at the end I'm going to bring the 1 back in. So you have x plus 3 over, factor the bottom, you're going to get x plus 5, x minus 8, right? It's just a simple trinomial sum product method. And we're going to equate that to a over x plus 5 plus b over x minus 8, just like that. Multiply both sides by that denominator to get rid of them. You get x plus 3 equals x minus 8 times a plus x plus 5 times b. Okay? Now we're going to sub in a value for x. Let's say we let x equal negative 5 to get rid of that b value. So you'll get negative 5 plus 3 equals negative 5 minus 8 times a plus negative 5 plus 5 is 0, so just 0, right? So negative 5 plus 3 is negative 2. Negative 5 minus 8, you're going to get negative 13 times a. Divide both sides by negative 13. A equals 2 over 13. Okay? So that's your a value. And then to find the b value, we got to get rid of a. So I'm going to make x equal to 8 to get rid of it. So let x equal 8. So you have 8 plus 3 equals, so you're just going to get a 0. 8 minus 8 is 0. Plus 8 plus 5 times b. So you get 8 plus 3, which is 11, equals 8 plus 5, which is 13 times b. Divide by 13, you're going to get b equals 11 over 13. So that's your b value. Now we have a and b. I can go ahead and put this together. I can say our original expression from the beginning is equal to 1 plus that 1 because we have a 1 up here that we said we were going to bring back, right? This 1 here. So 1 plus, and then we broke this one up, so we're going to write that next. 1 plus a, which was 2 out of 13, divided by x plus 5, plus b, which is 11 over 13 over x minus 8. And you can simplify this. You could say 1 plus 2 over 13 x plus 5 plus 11 over 13 x minus 8, like that. You can multiply that in if you want, but that's good enough, I'd say. All right, just like that. So we've looked at what to do when the top exponent's smaller. You just do it the normal way. If the bottom exponent's smaller, you got to divide it first to figure out that it's 1 plus, and then you get a new fraction with the remainder over the denominator, right? And then that's the one you break up the way we've been doing. So let's do one more example. Let's say you have 10x squared plus 12x plus 20 divided by x cubed minus 8. Well, the problem here is that the bottom isn't factored yet, right? We haven't factored the bottom. And because it's x cubed, this is actually a difference of cubes, right? So if you want, you could factor this by doing some actual division here, right? Or you can save yourself the time and just recall from the last video where we do difference of cubes how to factor this, right? So you'd have 10x squared plus 12x plus 20 divided by difference of cubes. You do a minus b, so x minus 2, because those are the cubic roots of each of those terms. And you multiply by a squared, so x squared, plus a times b, which is 2 times x. And then you add b squared, which is 2 squared, you get 4. So if you were to do this the long way, you'd say, okay, x minus 2, we're going to divide that into x cubed minus 8. And to do that, you'd probably want to leave some spaces, right? You'd want to say plus 0x squared plus 0x plus 8, right? Like that. Or, sorry, minus 8. Like that. And then you do your long division, right? You'd get 0 as your remainder, obviously. And on the top, you'd get the answer, x squared plus 2x plus 4. If you want to do it that way, you can do it that way. Or you can remember the formula for doing a difference of cubes, right? So depending on what you have here, you might have to do long division, but you also might be able to just get away with something like this if it's easily factorable. Now, with this in mind, we can now go ahead and take care of this, right? If you notice, the degree on the top is 2. Degree on the bottom, if you were to expand this, would be 3, right? X times x squared is x cubed. And just to check, can you factor this any further? Not really. Like, what two numbers multiply to 4 and add to 2? Don't think there is anything, right? The only numbers that multiply to 4 are 2 and 2 or 4 and 1. Neither of those combinations will add to 2. So you can't factor that simple trinomial there. So it's completely factored, so we want to rewrite this now. We're going to write it as a over x minus 2 plus, now because the other factor here, it's not a binomial, right? It's a trinomial with an x squared. So on the bottom, you have x squared plus 2x plus 4, and instead of on top just putting b, you have to put something that's 1 degree less than this. So you're going to put bx plus c. So the thing you put on top is always 1 degree less than the thing on the bottom. We can talk about that here or in the past because 1 degree less than a binomial is just a number, just a constant, right? But 1 degree less than a quadratic would be a linear, right? A number times x plus a number, something like this. So that's what you got to do here. Now, so what we have is this thing equals this, right? I could have drawn it all in one line just to make it a little bit simpler. But what you're going to do next is multiply everything by those denominators to get rid of them, okay? And this I will write all in one line. What you end up getting is 10x squared plus 12x plus 20 equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Just like that, okay? Now we got to start solving for a or b. I'm going to start by solving for a. I'm going to do that by plugging in 2 for x. So I'm going to say let x equal 2, and you'll get 10 times 2 squared plus 12 times 2 plus 20 equals a times 2 squared plus 2 times 2 plus 4. And then 2 minus 2 is going to be 0, so that whole term goes away, and you just get plus 0. So 2 squared is 4 times 10 is 40 plus 24 plus 20. That's going to equal 84 is equal to a times 2 squared is 4, plus 4 plus 4 is 12. Divide both sides by 12. A is equal to 7. Okay, so we solve for A and we get 7. Now we got to solve for B and C. How can we do that? Well, I think we could solve for C by making all the x's 0. Because if you notice, there's an x attached directly to your B. So if that's 0, B will go away. And also we know what A is now, so I can just plug that in. So let's just make x 0 to get rid of B. So let x equal 0. That's going to give you 0 plus 20 equals, A is 7, so I'm going to plug that in, times 0 plus 4, plus the B is 0, so you get 0 plus C, times 0 minus 2. So on the left you get 20. On the right, 7 times 4 is 28, plus C times negative 2 is negative 2C. So you move 28 to the other side. 20 minus 28 is negative 8, equals negative 2C. Divide by negative 2, C is equal to 4. Okay, cool. Now we just got to solve for B. To solve for B, what I'm going to do is set x to be 1. And you'll see why in a second here. Let x equal 1. You're going to get 10 plus 12 plus 20 equals, A is 7, so you just plug in A. So then you have 1 plus 2 plus 4, plus B is now by itself because it's just multiplied by 1 because it was bx, but x is 1. And the C we already know is 4, so you just plug in 4, and then minus 1. So the reason I plugged in 1 is so that B is by itself, plus we already have A and C, so you don't have to do anything to get rid of those. So just plug in an easy number like 1, and then solve for B. So on the left you get 42. On the right here you're going to get 49 minus B minus 4. If you multiply that out, solve for B, and you're going to get B is equal to 3. So now we have A, B, C, and you can say that your original statement is equal to A, which is 7 over x minus 2, plus bx plus c, which is 3x plus 4, over your x squared plus 2x plus 4, right? So we're following the same pattern we set out earlier up here, this pattern here. But now that we found A, B, and C, we're plugging those numbers into it, and that's how you get your final answer down here. Okay, and that's it.